Good morning, students. Welcome to chemistry class. In this video, we will discuss isomerism and types of isomerism. So let's start. First point is, what are isomers and what is isomerism? In organic chemistry, we come across the organic compounds which have similar number of atoms but differ in physical and chemical properties, or we can say that there are compounds which have same molecular formula but differ in physical and chemical properties are called isomers, and the phenomena is called isomerism. Now, types of isomerism. Isomerism is of two types, structural and stereoisomerism. Structural isomerism can be further classified as chain isomerism, positional isomerism, functional isomerism, metamerism, Totomerism, and ring chain isomerism. Whereas stereoisomerism can be further classified as geometric isomerism and optical isomerism. First is, what is chain isomerism? Compounds which have same molecular formula but differ in the order in which carbon atoms are bonded to each other. Or we can say compounds which have same molecular formula but differ with respect to the number of carbon atoms which are present in the parent chain are known as chain isomers, and phenomena is known as chain isomerism. For example, we have taken here N-butane and isobutane. Formula is same, C4H10, but in the first case, all the four carbon atoms are present in the straight chain parent chain, whereas in the second case, three carbon atoms are present in the parent chain, whereas one carbon atom is present in the form of side chain. So the first molecule is butane, whereas the second one is isobutane, or we can say 2-methyl propane. Both are having same molecular formula, that is C4H10, and are chain isomers. Next is positional isomers. Positional isomers have same molecular formula but differ in the position of a functional group on the carbon chain. Example, we have taken here alcoholic functional group. In the first case, OH group is present at position number 3. So this is pentane 3-ol. In the second case, OH group is present at position number 2. This is pentane 2-ol. And the third case, OH group is present at position number 1. So this is pentane 1-ol. So all these three compounds differ with respect to the position of functional group. So they are known as positional isomers. Next is functional isomerism. Functional isomers have same molecular formula but differ with respect to the functional group. Alcohols are functional isomers of ethers. Here we have taken example of ethyl alcohol and dimethyl ether. See, in both cases, molecular formula is same, that is C2H6O. But in the first case, functional group is OH, whereas in the second case, it is a ether. So ethyl alcohol is a functional isomer of dimethyl ether. Next is metamerism. This type of isomerism is due to unequal distribution of carbon atoms on either side of the functional group, or we can say such compounds are member of homologous series. Here we have taken example of diethyl ether and methylpropyl ether. In the first case, on both sides of the functional group, two carbon atoms are there, or you can say ethyl group is there on either side of the functional group. So name is diethyl ether. Whereas in the second case, one carbon atom is there on the one side of the functional group, whereas on the other side, three carbon atoms are there. So it is methylpropyl ether. Molecular formula of both the compounds is same, but they differ with respect to the distribution of carbon atoms on either side of the functional group and hence are known as metamers, and this phenomena is known as metamerism. Next is Totomerism. Totomers are constitutional isomers existing in easy and rapid equilibrium by migration of an atom or group are known as tautomers. You can see here we have taken example of acetone where ketonic functional group is present. When one hydrogen atom from methyl group will be migrated on oxygen atom, so resulting molecule is enol, which is prop1ene2ol. These compounds exist in rapid equilibrium and are formed by migration of an atom or group of atoms. So these are known as tautomers, and this phenomena is known as Totomerism. So students, we have discussed about structural isomerism in this video. Thank you.